Loops are a really important topic in programming, so we're going to spend a video doing a couple of in-depth examples of using loops to compute things. So let's return to the higher or lower game, which we described a couple of videos ago. In the higher or lower game, the computer chooses a number between 1 and 100, and we have to guess what that number is. And the rules are that if the guess is wrong, then the computer has to tell us whether it was too large or whether it was too small, and on the other hand, if it was correct, then the game stops. So the game repeats until our guess is correct. In other words, it repeats while the guess is wrong, and that's a clue as to how we can implement this game using a while loop. So let's have a go at doing this. As before, we begin with some code which generates a random number. Don't worry about what import random means or what random.randot is. You'll learn about that later on in Math 11. But we're going to begin then with our secret number secret, and we will have to start with a while loop. So we should have while the guess is wrong. So while the guess is not equal to the secret. And we need to keep repeating until that condition becomes false. In other words, until the condition becomes equal to the secret. So what do we need to do? Well, inside the while loop, what we should do is get the new guess. So guess should be the required using input. Enter your guess. And of course we need to convert that guess into an integer because input always returns a string. So we'll use the int function to do that. Next we need to do a conditional to adapt our behavior depending on whether the guess is too small or too large or exactly right. So if the guess is less than the secret, we'll print out too small. Then if the guess is bigger than the secret, we'll print too large. Else, finally, if the guess was the correct size, we should print you win. Okay, is that all? Well, actually there's something wrong here, isn't there? It doesn't quite work. So think of what's going to happen the very first time I run this code. Lines 1 and 2 will generate this secret random number. And then on line 4, we'll try to check whether the guess is different to the secret. But unfortunately, the guess doesn't exist yet because we only get the guess on line 5. And we need to get the guess over and over again. So we do have to have this guess inside the while loop. So in fact, what we should do is just begin by setting the guess to something which can't possibly be correct. So for example, we could make it -1. That can't possibly be correct because the true guess is between 1 and 100. And we're now ready to go. So let's just try it. If I run this, it asks me to enter my guess. I guess 50. 50 was too small, so I'm going to guess 75. 75 was too small, so I'll guess 87. 87 was too large, so it's between 75 and 87. Let's go for 81, which is too small, so 84. I've won. Okay, so it looks like our game is working. Right, so we now know how to use a while loop to implement the game that we were talking about 2 videos ago. Let's move on to a different example of using loops. So what we're going to do now is talk about Euler's conjecture. So Euler's conjecture was a very famous conjecture which said that you can't have the sum of fewer than k kth powers equal to another kth power. Like you can't have 2 cubes added together giving you another cube, or 2 fourth powers, 3 fourth powers equal to another fourth power. And the interesting thing about Euler's conjecture is that it's false. So in 1966, Landor and Parkin published a paper called Counterexample to Euler's Conjecture on Sums of Like Powers. And what they said was, it was a very, very short paper actually, this is the entirety of the paper, and they said a direct search on the CDC 6600 yielded something to the 5 plus something to the 5 plus 110 to the 5 plus 133 to the 5 is equal to 144 to the 5, as the smallest instance in which 4 fifth powers sum to a fifth power. Now, as you can see, unfortunately, somebody has vandalized this paper, and we can't see what the first 2 numbers in this counterexample were. So we're going to work out, using 2 for loops, what these numbers actually should be. So just as an aside, the CDC 6600 mentioned was a type of computer. It was a mainframe computer made in 1964, and it was the fastest computer in the world at the time. It had 128 kilobytes of memory, which is a few tens of thousands of times less than the amount of memory your phone has. It had about 2 megabytes of storage, which was getting on for 100,000 times less than what your phone has. It was the size of a small room, and it cost $8,1964. In today's money, that's about $60 million. And if you look carefully on this picture, so I'll try and indicate just here, this is the picture of the CDC 6600. It's, as you can see, very large, and it had a control console with 2 round monitors. But if you look at the bottom right here, you can see a little bit of copper piping. That's because the CDC 6600 made so much heat that it had to come with its own Freon refrigeration system. If you'd like to learn more about the CDC 6600, there are some links on the PDF version or notebook version of these slides where you can click them and learn a little bit more about what this thing did. Okay, so here is the equation that we're looking to solve then. We want to know what A and B are to make this equation true. So a to the 5 plus b to the 5 plus 110 to the 5 plus 133 to the 5 is equal to 144 to the 5. So how could we do this? Well, we're just going to do this in the simplest way possible, which is to try all of the possibilities for A and all of the possibilities for B. Now, we know that A and B must be somewhere between 1 and 100, say, because otherwise A and B would just be too large for this for this to be true. So actually, let's say less than 144. So we'll begin with a for loop where we say for A in range 144. And then I also want for each value of A to try out all the possible values of B. So the way we're going to do this is just by having another for loop inside the first for loop. So we'll have for A in range 144 for B in range 144. And that will try each value of A in turn. And for each value of A, it will then try each value of B. So we know that we will have covered all possibilities for combinations of A and B between 0 and 144. And that way, if there are any solutions, we're guaranteed to find them. So for A in this range, for B in this range, what should we do? We just want to check whether we found a solution, and if so, we want to print it out. So if A to the 5 plus B to the 5 plus 110 to the 5 plus 133 to the 5 is equal to 144 to the 5. Okay, remember, 2 equal signs must be used if you want to test equality. What do? We should just print out A and B. Okay, that's it. That's all I want to have in my for loop. Let's run that. Okay, there we go. We found our 2 solutions. So the solutions are actually they're the same. It's just 27 and 84 either way round. Those are the only 2 solutions between 0 and 144 to this particular equation.